Hello all, welcome to the video lecture series for the subject operating system. As I discussed in the introduction part about what is disk scheduling algorithms and the outcomes of that algorithm, we are going to start with FCFS, that is first come first algorithm. Say for example, we are going to have how this disk scheduling is actually working from any part of the algorithm. Generally, this disk scheduling is used to minimize, or else I can tell you the goal of this disk scheduling algorithm is to minimize the seek time, maximize the throughput, and minimize the latency. So that is all about the main objective of this goal. And also it includes the efficiency in resource utilization. That is a part here, right? We have seen this resource utilization much deeper and much thorough in our disk scheduling algorithm. That is all about CPU scheduling, how the resource has been utilized very effectively in deadlock algorithms also based on the availability and request. But here we are going to see much different when we compare with our CPU and deadlock resource utilization. Here we are going to see how this disk has been used this performance and use this request based on the position of read and write head, which is located actually. Right. We'll start the session with the first algorithm called first come first serve. Right. So here there is a sequence has been given. Suppose the order of a request is, these are all the positions, that is 82, 170, 43, 140, 24, 16 and 90. And these are all the request has been made by the process which is to read this particular request in a disk, and the current position of read and write head is at 50. We cannot say that this read and write head is exactly on 50. It may be any position where it has been left at the previous read and write position, right? So you can see here, this is the horizontally I have ordered this. I have taken this particular request. So here the head will be always between 0 and 199. And these are all the requests. I have ordered this request from ascending to descending order. You can see that 16 is the base, and then from small to bigger number I have been arranged in sequence. So that will give you the perfect example of how this seek movement has been actually moving. Okay, so let's start. Now see, the position of the read and write header is at 50. So here the 50, right? Now this particular position has been reading, and this algorithm serves which request first comes will be served first. Here you can check that the request for this first come first serve is 82. So now the head will slightly move to the right and it will be exactly placed at 82, right? I will mark an arrow so that you will understand where it stops exactly at 82 it is. The next request is example has been given here, that is 170. You can check where is that 170 here. It is exactly moving that 170 here. So I am mentioning it as 82 to 170 has been moved. Right. After 170, what is the request has been given? You can check it here. It is 43. 43 is exactly here. So I can point something over here so that it is easy for me to link it. Yeah, the 43. And the head is exactly residing at 43. It will look for the next request, that is 140. 140 is exactly here. I will place some 140 here. So here it is 140. So it is easy for me to trace this particular arrow from one direction to another direction, right? Now let's see what is the next request after 140. It is 24. So we need to see where is that 24 here. You can check the 24 is here. So I am putting somewhere here so that it will be easy for me to trace this information from one end to another end. Yeah, the head exactly resides at 24 now, and it will check what is the next head position. The request is 16. So now it will slowly move to 16 is very near here. So I'll make this request like this. It is at 16 now, right? And it will position the last request is 190, and the last request you can see that 190 is exactly here, and I'm going to position this 190, and the head is going to travel from 16 to 190, right? So this is the last request has been made by the process, so it exactly ends at 190, right? Now we are going to calculate the request with the current position and the total head movement which has been required here, right? So let me take you to the process directly so that you can understand this calculation very clearly. Now the total overhead movement, right? So we are going to see that how this total overhead movement has been calculated. Now here this arm disk, that is the covered by the disk arm, is equal to, we are going to see that how exactly it is. See, I am going to take this 50 82. So I am always taking the biggest number that is subtracted with the smallest number. So here we can see that the first head position, so you can check it from 50 to 82. So I am going to reverse this for the answer that should come, that should not come in minus. So 82 minus 50. So this is the first position, right? Plus, what is the second position? You can check it over here. The second position is, it has been moved slightly from 82 to 170. So as I told you already, the second position header is 170, that is a bigger number, that is subtracted with 82. Okay, I hope you understand this first two movement. And the third movement, I'll point this movement also so that it is easy for you. First movement, second movement, this is third movement, and this is fourth, this is 5, this is 6, and this is 7. Totally we have 7 head movements, and we are going to subtract all 7 head movements, and we are going to check how effective it is. If it is with the lower number, it is very effective. If it is with the higher number, let's check how this operating system is actually dealing with. Okay, so we'll go for the third head movement. The third head movement is from 170 to 43. So I am going to take, this is plus, this is third one. So this is third one, 170 minus 43 plus. Okay, so what is the fourth head movement? You have 43 and 140. So 140 is the highest number, so I am going to take that. So here it is, you can check it, that is 140 minus 43. So this is the fourth head movement, right? And then plus, what is the fifth head movement? You can check it, that is 142 24. Initially it is 24, you can check it, 140 to 24, that is the fifth head movement. So I am going to take that, that is 140 to 24 plus. After that 24, you can see that 24 is taking the sixth head movement is 24 to 16. So 24 minus 16. So this is fifth head movement, this is sixth head movement. And finally we have one more head movement, that is 16, and it ends in 190. You can check it over here. So it starts with this last head movement, that is seventh one, 16 and 190. So as I told you, the biggest number you are going to take first, 190 minus 16, right? So we are going to check what is the final answer we are getting on this. So 82 minus 50, 170 minus 82, 170 minus 43. This is the fourth, fifth, sixth, and this is the final one, 7. Finally, 1, 2, 3, and finally we are getting around 642. So what is the 642? Is the total distance covered by a disk arm. So I can write it over here. Total disk covered by the disk arm. So let's check whether this 642 is the effective disk arm total position, or else we have 6 different algorithms, right? We are going to choose which among this particular 6 is better movement of disk arm, right? So this is all about how to calculate the disk scheduling, that is first come first serve algorithm. Hope you guys have understood. Thank you.